My name is Mohit Basin. I'm on the product marketing team here at Prisma Cloud by Palo Alto Networks. And me and Vinayak are here to talk to you about DSPM and DDR. I have a background in computer and electrical engineering, and I got my MBA from UC Davis. So I'm super excited to talk to you about everything that Prisma Cloud has to offer. Vinayak, do you want to come up on stage?
Thank you. Hey everybody, my name is Vinayak Shastri, and I'm one of the product managers working with Palo Alto Networks with Prisma Cloud more specifically, driving data security and threat detection within Prisma Cloud. So a little bit about myself, background, before Palo Alto, I worked with VMware, Synopsys, and a company called Barracuda Networks. And majority of my career, I've been a pre-sales engineer, so I understand from that perspective if you have any questions around implementation, so I get hands-on a lot. So today we'll be talking primarily about data security and revolutionizing data security with data security posture management and data threat detection and response. So thank you for having us, and we'll talk to you guys in a second. So Mohit, take over.
Thanks. So before I get started, let me just ask a question. How many of you know what Prisma Cloud is and what we do here at Palo Alto Networks? Okay, so a good amount of you. But for those that don't know what Prisma Cloud is, it's our cloud security business here at Palo Alto Networks. It's our code to cloud security platform. And it was built on three main key principles on the fact that we wanted to build complete and consistent security across different cloud security or cloud vendors, CSPs, and different application components. We wanted to deliver best in class security on each own by itself, but when combined together, they work together and we can correlate risk. And then the last one is we wanted to cover the full application lifecycle. So we wanted to provide security across the build, deploy, and run phases of when you build cloud native applications. And today, we secure some of the largest cloud environments today. We're trusted by a few thousands of customers, as you can see on the slides. And we're looking forward to taking that to the next level with data security. But before we talk about data security posture management and data DDR, let's first talk about what Prisma Cloud does for customers today. In a nutshell, we do two critical things. We help you reduce risks and prevent breaches. And how we do this is we embed security across the application lifecycle because we know that when you are building applications, they just don't show up in runtime one day. They all start as code somewhere, whether it's open source code, whether you're making and standing up infrastructure as a service through Terraform or CloudFormation or different tools. You're eventually building the application and then you're deploying it into runtime. And that's what we want to do. We want to help you cover the entire application lifecycle by embedding developer-friendly security on the very left and then helping you prioritize risk as well as giving you application context into risk at runtime. And then as the last line of defense, we want to make sure that you have always on protection against the latest threats you may see in the cloud environment. And what our customers have found is that we're helping you enable your developers to be more efficient by reducing the risk in code and shifting left. And then we're empowering your security teams on the right to prevent breaches and take that actionable information to developers to go be the heroes within their organization. Now, I know this sounds kind of a bit vague, so let me give you a specific example. I'm not sure how many of you heard of the XCL utils vulnerability. Raise your hands. No, yes. I'm sure all of you have heard it. Some of you guys are giving me sarcastic looks in the audience, but this vulnerability was found by a Microsoft researcher when he was just looking at how or why the performance of a certain piece of a library was not meeting up to par. And when this supply chain vulnerability could have not been found, it would have eventually led to multiple vulnerabilities in production, which could have led to multiple backdoors into your environment. And where Prisma Cloud comes into play is, let's say that your developer deploys this very common library into a container that's running on an on AWS, and it's actually exposed to the internet. What we help you do is we help you showcase where that vulnerability is, and then correlate the risk on, hey, this is on an EC2 instance that is exposed to the internet, and then we're able to tie that vulnerability all the way back to what registry it came from, who's the owner, as well as what package it came from, and who's responsible for going and fixing that package version. And that's what we're able to do. We're able to correlate that risk across the application lifecycle, so you're able to take what you know today, correlate it back to secure everything from code to cloud.
I have a question. I just want to clarify.
Yes.
You said that you can identify the affected versions of the library and trace deployment. You're saying you can find the vulnerability after it's been reported. You're not saying that you could have detected it before it was
correct.
committed.
Yeah. So if they deployed that vulnerability and we know of it, we can see it in production and then correlate where that vulnerability originated from in code where the developer pushed it. We cannot.
I'm just making sure because some people were claiming they could, and those people are liars.
Yes.
And I just wanted to make sure that you were not.
We did not. Like I said earlier, the Microsoft researcher found the vulnerability because he was looking for performance issues. We did not. So he.
But once you know that that is an affected version, then you can trace that through your deployments of whatever you're doing to trace back what happened and where, so that you can know that you're not affected by it.
Exactly. So you can, like you said, search your entire infrastructure or all your cloud estate to see if that vulnerability does exist in production. If it does, then you can, rather than fixing it in production one by one or hundreds at a time, you can take the power of knowing where it originated from to fix it once in code and then redeploy.
All right, just checking.
Yep. And that's a great that's a great point. I'm glad you brought that up because what we're seeing now is it's not enough to know where the risk is in production, because what we've realized is that at the heart of most breaches, attackers are looking for data and they're trying to exfiltrate data. So what we did recently was acquire a company called Dig Security and integrate it into Palo Networks because we want to know where the sensitive data is that attackers are looking for, and then that way we can actually work backwards to prioritize risk on what to focus on. With that, I'm going to pass it over to Vinayak to talk more about DSPM and revolutionizing data security.
Thanks, Mohit. So we've heard about the contextualization between code to cloud in this particular case, right? So in any security context, let's go back, take a step back. In security context, when you hear about a breach or an event or a company lands in the news, what is the reason behind it? Right? Going back to the reasoning up here, one reasoning around
data loss.
Exactly. We lost 50,000 records of social security incidents or PII data, PHI data, credit card information that was actually lost, passwords, username. Everything maps back to data. So what did we think in this whole ecosystem around? Code to cloud is good. It's providing me visibility of how do I trace back my vulnerabilities? How do I prevent my risk? How do I protect against any threat that might be happening? But at the end of the day, you have to look at it at a lens of data, right? What data am I protecting? Let's take an example. I have a set of risks that I come up with, right? Whenever we talk about a CSPM platform, as soon as you onboard, majority of the customers will see 10,000, 20,000 different alerts that actually come in. How do you sit and prioritize? Severity is one way, but you need to get to the understanding of where does it actually come from? What are you protecting at the end of the day? What is of value that you're actually protecting? Data comes into context. So we took out a lens and said that we should be looking at Cloud Native Application Protection Platform, which is our CNAPP platform, from the lens of data, right? And your application. Data is your crown jewel, as we call it, and application is your level 1 information at the end of the day. Business criticality and what is the value of it. And that's one of the reasons we actually looked at it and said, regardless of the vector of the attack, your vector could be a vulnerability being exploited. Your vector could potentially be an API insert. It could have been a user that was malicious trying to attack. Let's take any breaches, Capital One or any of those breaches that happened in the past, right? The vector could be multiple and infinite as you get in because your attack surface is such large and infinite. But the end goal for an attacker in majority cases is to get hold of your data. So how about look at it from a lens of data, understand what's out there. And when we talk to our customers, majority of the customers that we actually talked to had 3 different challenges in the cloud. And you'll probably resonate with the customers that you talk to or CISOs that you would actually come across. Majority of them had one major problem. They didn't know where the data existed, especially in the cloud. And the reason behind it is fragmented applications. Customers go deploy these applications in hours, minutes, and days, right? Unlike your traditional data center where I owned a data rack, I knew what was on my data center. Cloud, you can go spin up a database, a PaaS database, an EC2 instance with the DB on it within minutes, right? So this brought a different challenge because most CISOs didn't know what was out there. If you ask a simple question, do you know what all data sources exist and what data exists within those data stores? The answer was always no, right? So primarily, we went back and said, how do we actually provide visibility to customers that actually want to understand what is really, what is to be protected? The second part is, now that you know what's out there, what is the value of the data? How do you understand who's using it? Cloud provides a different problem. You can have multiple touch points. It's not only your application that's actually utilizing it, you could have an external entity accessing your data. You could have multiple internal services or instances or users that are actually utilizing the data. The identity control plane is actually vast in the cloud. So this provides another problem to understand. Now that I know where my data is, now that I know what type of data exists, who's actually utilizing that data? What are the different touch points for that data? This kind of gets into the misuse of data, or the compliance reasons that I need to go back and understand how do I restrict access to the data point. And finally, regardless of how much you can actually cover in terms of risk, your threats are always there, right? You got to look out for if there is misuse, internal misuse, external misuse of data. That actually comes in from exfiltration. Finally, you want to prevent exfiltration of data that's actually happening. So understand, even before a data breach happens, are there steps that are actually coming up? Are there attackers that are performing reconnaissance attacks in your network, right? So that's where we want to answer these three questions using data security posture management. And these are the primary questions that we kind of answer. Pivoting out to the cloud, the problem actually goes tenfold than on-prem, right? There is an explosion of data stores. We're talking structured data source, unstructured data source, which means I can have an S3 bucket with different unstructured files in there. I can have a structured database that I'm deploying, semi-structured data source that I actually deploy. To make even things complicated, I can lift and shift data stores. And this has primarily happened because organizations in the last 10 years have gone ahead and said, I'm going to move all my applications out to the cloud because it's effective, it's faster, it's cheaper in some cases, right? And this has actually brought in a ton of data stores. To give you an example, like we build an application internally at Prisma Cloud. Each app or a microservice app itself has at least 10 different data stores. And within one product, we're talking about hundreds and thousands of applications. Right? Think about a simple applications that you go back and then ask a developer, how many different data stores does your app actually touch? It's not just one or two, it's usually multiples. Now multiply that by the number of applications that the organizations actually own. This is the problem that cloud actually creates for CISOs, where absolutely no visibility into what's really out there. To add on to this problem, there is the whole change of applications not only communicating within the cloud, but also database as a service. Right? You have Snowflake and Databricks that comes and says, don't worry about scalability. We'll actually go deploy it on our cloud. Have your cloud applications talk to us. Right? And that's now exploded into a session where it's not just in your CSP or cloud service provider, but it's outside of it. How do you manage these? This is in the past 10 years, right? In the last few months, things have changed where it has actually gone 10 to 100 folds on top of it. The responsible actor on that is GenAI. GenAI requires, your GenAI applications that you actually control requires a ton of data, right? For you to sit and train a particular GenAI, understand what kind of training data set it's actually consuming. Some actually consumed through structured, unstructured data sources. There is inferred data source after that to confirm, right? And then there is the output of GenAI that actually goes into a different data store. This has taken existing data stores to 10 folds, every GenAI application actually consumes more data. So this brings in more challenges in terms of expanding the ever-expanding data stores in the cloud. So, so we've actually gone ahead and seen the challenge that the CISOs face, and this is ever increasing with the number of data stores that actually exist. So how do you go protect these data stores in the cloud, right? The biggest challenge that majority of the customers actually have is with discovery and classification. Now, in a traditional legacy world of data security, if you remember, a lot of times what happens is you manually use these connectors to connect to each database or data source, right? And that's impossible to do in the cloud because you just don't know what's out there. So discovery is very important for us to go do and understand what data types are or what data stores are really out there before you get into the data types within these data stores, right? So what we have actually done is build a no agent, no proxy way of discovering these data stores and the data type. We don't need the administrator to provide me a password to the database. We can automatically read the data in the database as we get more information. Now that we've passed the first part, which is I have complete visibility of all the data stores and the data type within the data source, I know the value of the data source. As a CISO, as a cloud security admin, I know where are my crown jewels in my infrastructure. The second part is to understand the risk around it. Right? 10 years ago, everybody probably came across this. Buckets were a concept, like data store, unstructured. I have an S3 bucket as a simple example. Right? Majority of the data breaches actually happened because of misconfiguration. Somebody left an S3 bucket publicly open accidentally, and there were sensitive data stored in the buckets that were exploited. While that is still the case with the few, but majority of the customers have adopted some sort of a CSPM solution or even native CSPM solutions to actually protect against those, right? Those are basic protection or security policies that you want to implement. But the complication is there are always weakest links to your channels. Your Cap1 attack, for example, the data source by itself was actually not exposed, right? It was the web application firewall that actually had access to the data stores. So the way that I look at security in the cloud, lateral movement, in other words, happens by network, also happens by the identity source. So it's not only I'm connected to a database, but I can even access the database because of the identity that I actually have. So this provides static risk identification to understand what is the posture of that data store. Is it encrypted? Has anybody disabled logging on that? Is it exposed to the internet? Are there other misconfigurations on it? And there are three different types. One is misconfig, simply. Somebody has turned off encryption. Somebody has turned exposed to the internet. Then there is access, which is I have an overly permissive access bucket or a database that I've accidentally given everybody access to, or I've given an external identity access to my database, and I forgot to take that access permission. And finally, data sovereignty, right? And this is very important, especially in this field, because everybody has localized data sovereignty laws. You have GDPR in EU that ensures that no data actually leaves EU region outside, right? And you ask every single state, they would want to make sure that the data actually resides within a particular location as required, right? So this is very important. So we'll discover and talk a lot about static risk identification and how we do it today. Combining these two, we kind of call it as data security posture management. So the cloud security admin has visibility into what type of data stores are out there, what type of data exists. So I know all the crown jewels. And two, what are the open risk that could lead to an incident, right? So these are just open risks that I've kept the window open. Somebody could peep in, but nobody is. So that's data security posture management at the end of the day. Then comes real-time detection. Remember, it's not enough to just close your risk. Threats are going to come on board at any point in time, inevitably. So essentially, what we talk about is data threat detection and response. DDR. Right? In the cloud, we say cloud detection and response for CDR in general. Very specifically doing that to data events, we talk about data detection and response. Right? These are any attacks that could be happening in my infrastructure. It could be a reconnaissance attack, somebody trying to assess what's in a bucket by enumerating it, right? Or even identifying, tell me how many buckets you actually have. We consider that as a reconnaissance attack. So we'll talk a little bit about data detection and response. Altogether, we've actually looked at the whole SKU and said that DSPM and DDR are very important for CNAP to be successful. And this is one reason Palo Alto actually went and acquired Dig Security. Let's talk a little bit about data classification and discovery. Right? The first part that we actually brought in is how do we discover these data stores? Right? Challenges with legacy solutions is I need to go reach out to an administrator on the database and say, can I get access to your database with username and password? Temporary username and password to be more precise. Right? And then I'll be able to read the type of data, understand what type of data exists, and then label them. That's the legacy way of doing it. The problem with those solutions, customers have years and years of implementation timeline, right? Because it's impossible to find out one by one who owns the database. Can I connect with the database? Can I actually understand the type of data? So we specifically looked at this problem and said it's very important for a vendor to actually have automated discovery of data stores, right? And automated classification without having to reach out to any administrator. And I'll tell it to you at a very high level. The way that we do it is essentially there's one part of it that is done by cloud logs, which essentially is I'm just going to reach out to AWS, Azure, GCP APIs and tell me what kind of data stores exist. Two, we'll be able to run backup snapshots for those instances and analyze those more specifically within the customer's environment without having to move the data out. Right? So data sovereignty and data privacy is within the customer's reach. No data moves out of their environment at the end of the day, but we're able to analyze what type of data exists using just those snapshots and backups.
So it's really interesting for me what you're presenting here because you talk about data, posture, security management, or whatever it's called. But a lot of what I'm seeing here talks more to me about data management. And I was, wondering if in the shadow data you're also able to discover dark data, or rather, kind of not just orphan snapshot, but also orphan data which has no owner, for example, and stuff like that.
That's the next part, which is very important in this particular piece. We call it data freshness.
Okay.
Right? A lot of times, snapshots are the reasons that breaches actually happen. Somebody took a database snapshot, left it out there. Now they're done with the database. They've deleted the database, but the snapshot still exists, which means there's sensitive data within the snapshot that could potentially be in the hands of an attacker. Right? So very good question that actually comes in. And the way that we look at it is we call it data footprint. And I'll show you during a demo, we're able to find out all the orphan snapshot that are out there that have never been used before, or all the data assets that have not been used in the last 90 days. Something for an administrator to rethink and say, why has there been no activity on this data store? Should I terminate it because it has some sensitive data? Right? So data freshness and the ability to provide all of those snapshots is very important because one, it is for us and our customers, it's a way for them to save costs. Look at all the snapshots that you currently have. If they're orphan snapshots, delete them out completely.
You're hitting on, I think, a key problem why we're seeing actually a lot of activity in this space on the part of data protection software providers, whether through acquisition or alliance activity. So if there are members of the audience that have maybe seen some of this activity from that side, I'd love to know from your perspective, what is kind of unique in the added value of this insight in the hands of Palo Alto Networks?
Right. So as I mentioned earlier on, if I understand it right, you're talking about how do we gain value from the data that we actually get from inside? So how do our customers actually gain value in the other hand, right? So one part of it is understanding the data type is very important for us to go protect the data asset itself, right? So Palo Alto with Prisma Cloud has findings, as we call it, coming in from different sources. It could be risk, which is what we call misconfiguration, and there could be misconfiguration on the identity aspect. It could be misconfiguration on a different aspect. To take an example, let's say I have an EC2 instance that is deployed and it is exposed to the internet. That by itself is a finding. Somebody has exposed to the internet, which is okay for an instance to be exposed because it might be running a web server. It's externally accessible. Two, but it has a bunch of vulnerabilities on it. That's being discovered by our CWP. And we specifically tell, we found these vulnerabilities on this particular workload. It could be from different sources. It could be from an application. It could be from an image. It could be from a version of library that it's actually hosting at the end of the day. And now we kind of get into the connectivity. With identity, I know that this EC2 instance can actually connect to an RDS instance that has sensitive data. And that's a critical risk for Palo Alto to tell our customers that prioritize based on the value of the data, right? In another instance, the same EC2 instance could be connected to another RDS instance which has no sensitive information, no data. So as a security admin, which one would you prioritize first, right? The first one is a P0, all hands on deck. Second one is I need to fix the risk, but since there is no data asset, it's a lower priority for me. And that's how we want to present it to our customers. That's why we call it a data-centric approach for CNAPP.
Vinayak, I have a question. It looks like this is more targeted specifically for cloud and data in the cloud. What about our on-prem data? Not everyone stores everything in the cloud.
Yep.
And I'd say a lot of businesses that are running their own apps have disparate data storages, some in the cloud and some on-prem. Does this cover the on-prem? Is there an answer for that? Is there a complement or a supplement for this, for the on-prem?
Yeah, we're slowly starting to get into it. Cloud is our main focus because that's where Prisma Cloud sees the value of providing end-to-end. We're slowly starting to see that these applications in the cloud are not only talking to data stores within the cloud, but they're also talking to database as a service. Some to SaaS as well. I could have an Office 365 solution that my application is somehow connecting to, and on-prem NFS servers as well. So we're slowly starting to see that. So Dig Security, originally as it started, focused initially on cloud. It moved into some of the other solutions around Office 365 as SaaS, and now they're getting into NFS as well. So as we see more proliferation of these applications, connectivity into different on-prem, cloud, and SaaS apps, we'll start moving them in there. But our primary focus is to actually share the security of those applications that are deployed in the cloud via the solution, right? Pure on-prem, there are different solutions out there in the market that actually do the same. But our focus primarily is from a cloud lens.
Yeah, I was just thinking, I know Prisma Cloud, but there's also the next-gen firewall, Palo Alto Networks is very famous for, and that's, a hardware box on-prem.
Exactly.
So for some businesses, some industries, some organizations, we already have that Palo Alto Networks touch point at our boundary, at our edge. How do we protect that?
So we do have what we call Prisma SaaS and Prisma DLP, which actually kind of moves into that particular field to say that firewall can now do inline transaction of DLP using these components.
Cool. Okay.
Right.
Thanks.
And just as somebody that has a lot of test environments where we have, like, we'll say just faux healthcare data, that way we can actually test our applications. Is there a way where we can kind of reject some findings of, like, if we have some like test patient data where it's obviously not actually real info, can we reject that data so it's not flagging as, say, an incident?
Absolutely. Yeah. So there are two parts to that incident, right? One, the data has to be sensitive, and two, there has to be a risk associated with it, right? If you, for some reason, think that the data by itself, we have flagged as sensitive, but it's not because it's test data, mock data at the end of the day, you can always call that a false positive and say, I don't care about this because it's a false positive. Or you can even accept the risk and say that I know my business unit has a requirement for this, and the data is not real data, actual data. So I can actually go ahead and accept the risk and say, I'll just pass it on.
Gotcha. Thank you.
Right? So now that we've talked about discovery and classification, this is the hardest challenge to actually pass in the data security world because of how important it is. A lot of vendors either do the manual connectors or move the data out, which is even more problematic. Now I need to move petabytes of data from their AWS to another SaaS service where I would scan the data out, which compromises both data privacy and concerns from a customer perspective of letting that data.
Not to mention the egress fees.
That too. Plus, who bears that egress fee at the end of the day? That's expensive.
Yeah.
Right. So considering all of this, the classification being within the customer's environment was an easy solution for us to go big.
Talk a little bit about on that slide about the custom classifiers. What does that mean? Does that mean a customer can have their own classification for their data?
Absolutely.
And
So
how would you identify that? Would you write some code or something to then uniquely identify that specific customer's data?
yeah. So just like traditional DLP, right? We have classifiers that are out of the box. There are 100+ classifiers, which are a lot of times traditional DLPs have like 1,000+ classifiers that they actually go with. We start off with a lower number of classifiers, but which are more important for customers at the end of the day, right? But let's say I have a customer that comes in and says, for some reason, I need to detect all my auto VIN numbers and I have a custom classifier written for it. So customer would simply write a regular expression pattern for those and apply them. We would automatically detect all the custom patterns out as well. So there's out-of-the-box patterns, which are things like credit card numbers, for example, right? It could be first name, last name, social security number, credit card number. There's like 100+ patterns that we actually detect. But if there are customers that actually say, I have a list of custom patterns that I'd like to detect, you could bring them in as well, right? Those are simply regular expression patterns that are actually brought in. And we touched everything around unstructured and structured data, right? Unstructured meaning I have an S3 bucket with files, CSVs, and other files that can actually sit in. Structured data where I have a database. And then there is a third component, semi-structured, which is also a database that is actually accessible with the semi-structured data. Now that we have identified the crown jewels, the next part is actually risk identification around data security posture management. Right? I know where my crown jewels are. Now I need to know if there are misconfigurations on that particular crown jewel. And this is what DIG actually did well within the context of the data store, which means I can tell you if that particular data store has logging enabled, disabled, encryption enabled, disabled, just by looking at the configuration of that particular data store. Right? And prioritize it. Like if sensitive assets are unencrypted, that's a high priority for somebody to go look at and figure out why it's not encrypted. If it is unencrypted and publicly exposed, that's like P1 risk for me or P0 risk at the end of the day for somebody to go take a look at. And then there is compliance, right? We talked about GDPR compliance earlier. If I have PII data in Europe and a user or an entity in North America is accessing it or Asia is accessing it, and there is an alert that goes in and says that I see data flowing out of Europe that contains PII data. So it's important for them, and this goes into a very prioritized list for the customer to look at and say that these are P0s, P1s, and I'll even walk through a demo of how customers can create their own custom risk. If I'm interested in something very specific, let's say in GCP, I'd like to make sure I have no sensitive data such as secrets, for example, that's exposed publicly. Developer secrets. So alert me if you see developer secrets on my GCP application immediately. Right? And then you can create a workflow for this. Most customers would receive these alerts and say, how do I fix it? Everybody has a different way of fixing things. In most cases, it is the data owner that's responsible for fixing it, or the asset owner is what we call it. If it's publicly exposed or unencrypted, reach out or create a ticket via Slack, email, webhooks, Jira integration at the end of the day, to ensure that the right and appropriate asset owner takes the remediation with all the context provided around it. So in this case, what happens if this is not remediated, potentially would have a breach or could have a breach, right? And so our next goal is to ensure and identify what is happening on those data stores, who is accessing those data stores. And I'll show you during a demo, we actually click on the identity part as well to show who has access to those data stores. And we kind of break this down into the 5 different categories, which relate back to MITRE at the end of the day, right? Everybody's familiar with the MITRE framework. Most SOCs admins prioritize threats based on these MITRE framework. We map them to MITRE so it's easier for customers to prioritize them. If it is a reconnaissance attack, there's no remediation, but keep a watch out for that particular user because they're actually performing some sort of check, right? If it is a first move, somebody is disabling logging, somebody is disabling encryption on that particular asset. This actually takes to the next alert, saying that I have a user that has never accessed a data store before, but all of a sudden I see them enumerating data store as 3 buckets and trying to go ahead and disable logging on that particular S3 bucket, right? Which is a red flag right there. So before the user can actually attack the asset or exfiltrate the data, you can take the next step of going back and quarantining the user or figuring out, ensuring that the instance or the user responsible for this is quarantined from making the next step. So this is what we call DDR, and we'll go through some of these policies during the demo itself. So overall, the way that we look at the lens of data security in cloud more specifically is both DSPM and DDR. You need to understand where your valuable crown jewels are, understand the risk, and ensure that you have visibility to any threats that are actually out there. So to do that, we've kind of defined discovery classification, risk, and real-time DDR across the board. Remember, we do this with no agents or proxies, which is easy for us to go and understand what kind of data exists without having to tamper or without having to insert agents in your system at the end. So it's zero interference with your production environment when we're looking at a production database. All right, I'll take a pause before I go further.
No, I guess I'm very interested in the demo to see how it all fits in. Obviously, Palo Alto Networks has lots of various security offerings, both on-prem and in the cloud, and we don't want this just to be, just another dashboard and another tool, right? How does it integrate to the whole family of products that they have?
And I'll show you a classic example of an attack, and Prisma Cloud is behind it at the end of the day, right? We want to put these whole attack paths that actually lay out risk, threats, and bring in the value of application context and the data together.
I kind of feel like this is, and correct me if I'm wrong, and maybe I'm simplifying it too much, so I don't mean to insult, but it almost sounds like, cloud architecture and cloud networks for administrators and engineers to build and manage can become so big. They are already so complex.
Yes.
And the way that data moves between the app and the database and the storage and this, it can become so complex and overblown that it's easy to miss the low-hanging fruit. And it almost sounds like this is just finding the low-hanging fruit for you and just saying, here, this is open here you have data here. Here's places where you need to tighten up in a cloud architecture with regard to where you're storing your data.
So what traditional DSPM vendors do is bringing that low-hanging fruit, right? Tell me that what is the risk around the data store? But where Prisma Cloud takes it to the next level is brings all the correlated events across the board from risk and threats and identity alerts together in one place to provide that broader understanding, right? Took an example earlier on which says, I have a database. In majority of the cases, nobody makes the database public. They're careful enough to have a private database and then secure it according to network architecture and all of that end of the day, right? But you could potentially have an EC2 instance connecting to that database via an identity. I have given a permission to the EC2 instance to have a permanent role to make a call to that database at any point in time, right? But that EC2 instance is actually the weak link in this particular case. It's exposed to the internet. It has vulnerabilities. And somebody actually either breached using a vulnerability or it was an insider attack that actually triggered a call. Once I compromise the EC2 instance itself, I now have access to the data store that EC2 instance can replicate. Identity makes it complicated. It sounds simple, but as you said, there are different ways. It could be network, it could be identity, it could be different paths that actually can come in. If the EC2 instance, for example, has admin privileges in the cloud, an attacker could spin up another instance, ensure that that instance actually has access to the database, backtrack and delete everything as required. So identity becomes an important lens as well. With just pure DSPM, you're not getting access to the identity lens. You're not getting access to the cloud lens. You're not getting access to the vulnerabilities in the code where the vulnerabilities that came. What we're trying to bring in is those pictures together, say that we will provide you a way to understand both risk and threats from code to cloud, but look at it from a lens of data at the end of the day as well. Make sense? I'll show the demo and I'll show all
Vinayak,
of them.
one question. Do you have like an example of, on average, how long it takes customers to set up DSPM and DDR?
Good question, because earlier I spoke about legacy vendors taking years to actually process the data, understand, connect. The way that we actually function and work today with cloud native APIs, it's a quick onboarding that takes less than 5 minutes, right? And within the first 5 minutes, you see all the cloud assets. Within the first 24 to 48 hours, you'll start seeing the data and those assets as well. Right? Again, it depends on the scale of the environment, but majority of the customers see initial value in the first 48 hours, and discovery of asset is just a 5-minute process. Right? If you've onboarded a cloud security posture management tool before, that's exactly all we're asking for is access to cloud native APIs. Can I use your AWS credentials or APIs to make certain calls to understand? So read-only access to understand what kind of data stores you have, right? To get all the value around. Second thing for DDR, we need to ingest cloud logs. This could be CloudTrail, event logs at the end of the day. In order for us to understand what's happening, we need to ingest all the cloud detection logs at the end, right? For something like AWS, call it CloudWatch logs at the end of the day, be able to ingest those. So it's real-time event detection. If a user automatically makes a call to a data store, I immediately know because of the logging that somebody's trying to access the data store. So it's real-time at the end, or cloud real-time as we process it. Third, most important piece, the data never leaves the customer's environment. This is what we call an outpost deployment, because all the data classification and analysis happens within the customer's environment. Yes, we spin up a stack in that region to understand what kind of data goes by or what kind of data it has. And it depends if it is a backup, snapshot of an instance, or an export of a database that we can actually go look at. Right? So this also gives access to both managed and unmanaged, and I'll take an example of it. So from years of implementation, customers come down to days of implementation. In most cases, 24 to 48 hours, they actually receive an understanding of what are the different data stores, what are the different data within those data stores, right? Without having to talk to a third-party admin. Questions?
Yeah, I do have one question.
Yes.
From the security perspective, it seems pretty clear what your customers are within an organization. But what about, let's say, if I look more at the business value that this is bringing, not just from the securing the environment, but all of the things related to the classification, making sure that we are adhering to compliance regulations and so on. Who are your stakeholders within the organization? Who are you talking to?
Yeah. So as you said, primarily we're targeting two stakeholders around cloud security admin,
so
right? And then data security.
So you don't talk to kind of a data officer or CIOs or people like that?
We are. So our primary persona is typically either cloud security or data security officers. At the end of the day, with data, we kind of overlap a little bit in place. But our secondary personas, as I said, could actually, as you mentioned, could be a compliance regulation that I actually need to understand. So an auditor might come back and say, I need to understand where are all my PII data across the globe.
Okay, I'll touch base in the breakout session because I also have some questions related to what you said about on-prem versus cloud.
Yes, we could dive deeper into it.
Interesting, thank you.
So definitely there are secondary personas that we kind of support, especially around the compliance side, data officer side. Depends on the use case more specifically around, right? Because a lot of times when you talk to DOs, essentially that kind of brings into one piece, which is they don't differentiate between on-prem data and cloud data. It becomes one bundle. So one last thing, without AI, I don't think we're going anywhere at the end of the day. So everybody wants to have an AI within a particular tool. Gen AI is the latest application, so we're actually introducing around it. Every company, every product out there has some sort of a Gen AI tool that they want to introduce, right? And this is actually creating another problem in the cloud around data and the Gen AI apps. So every cloud vendor has their own Gen AI app, Azure OpenAI for that matter. A lot of customers have adopted. And essentially, this provides two challenges to CISOs. I need to know all the Gen AI applications that are out there and understand what data sources are they connected to. And this is very critical, right? Primarily, Gen AI applications have become so common that you're asking interactive questions to get a response back. What if the Gen AI application has access to a data store that has financial data of a company, right? So, and this becomes critical because I now, an attacker could probably probe the Gen AI in such a way that they could actually get financials of upcoming quarters. Gen AI doesn't differentiate what kind of user. So it's important to actually ensure what are you training the Gen AI with? What infer data are you utilizing to train your Gen AI with? And that brings us to our DSPM's next leg, where we call AI SPM, AI Security Posture Management. Where primarily it's two legs. One is discovering all the AI modules that are actually running, primarily all the managed models that are being provided by the vendors, and essentially connecting them to the risks that are associated. Think about it from a same DSPM perspective. I'm telling you if your AI SPM model has been exposed to the internet. Is it configured in the right way? Understand all the different pipelines. Two, map them to a data store. DSPM already has complete visibility into risk of a data store. Tell them that this Gen AI application is connecting to a data store that has financial information. And it's being trained by that particular financial information. So you could take the next step to actually disconnect those two immediately, right? And then finally, the same data detection and response, where we make sure that there are no real-time attacks on AI models that are actually happening. And if we do, we flag them out. So we provide a complete scope of how the AI application is communicating, what data sources that they're communicating to, what applications are they connecting to. So you have a visual understanding of how that is actually phased out. So this is a part of AI security posture management that we're actually introducing soon. So this is more of a coming soon piece that we want to bring in.